Okay, done. What's the probability that the first one is red? Okay, sorry, let me draw the tree diagram first. Okay, so the tree diagram that should be, I think, should look like this. Okay, I will leave it to you to write your own key. Right, so in part 1, the probability that the first pen is red, what would that be? 7/12, right? Okay. Then part 2, probability that the pens will be in the blue-blue combination. First one is blue, second one is also blue. Oh, sorry. Second is blue. Even first is blue. Okay, so what would that probability be? What would it be? Sorry? 5/12. Okay, so we are given that the first one is actually blue, and the second one, we want it to be blue as well, so that will be 5/12. Okay. Then after that, probability that blue will actually be Ellie. 25/144 because 5/12 times 5/12. Okay, so we get 25/144. Then after that, part 4, we want to find the probability that the second one is blue. Okay, so we consider the two cases, okay, of red blue or blue blue. Okay, I'll explain later on why is it that it's better to consider in such a way, right, when we explore dependent events. Okay, so red blue will actually give you 7/12 times 5/12 plus blue blue will be 5/12 times 5/12. Okay, so in this case we will get our answer to actually be to actually be 5/12. Alright? Yes, but actually, right, you realize that maybe going through with this will be better than to remember always is it independent or dependent. Yeah, because I don't want, okay, what Brian is here asking, right, okay, whether for independence, second is blue, you want to always just take this probability. Second is blue, right, okay, yes, independent events, yes, you can take that probability. Okay, but then the thing is that I don't want you to actually end up having to have trouble trying to distinguish whether is it independent or dependent or not. Okay, because later on dependent, you will realize that it's necessary for you to consider in this combination rather than taking the probability. Because you know that in the second pick's probability, it will change, it will be different from the first one already. Okay, so that's why it will be advisable for you to actually do in such thinking, okay, rather than having to always be wondering, is this independent or dependent? Because if you do in this thinking, right, it's regardless of whether independent or dependent. As long as you see your tree diagram, okay, you calculate, take your calculations correctly, then you will be able to get the correct answer. Yes, Kim?
Red, blue, orange, yellow, green, purple, black, white. It's like a lot, then you just do that.
He won't torture you that way, because it's a torture for me as well. Okay? Then after that, part 5, we want to find the probability that no blue was selected. So what would be an easier way to do this calculation? To consider red, okay, so you can consider probability of red. So that will actually be 7/12 times 7/12. So that will be 49/144, right? Okay, let me just tweak this question for here, right? Okay, now what if, right? Okay, if I were to change this, instead of being replaced, okay, so first pen is picked and then not replaced before second pen is picked. Okay, so this will affect the probability that we have over here, right? Okay, so what would the probability be over here for the second pig blue if the first pig were to be blue? What's the probability going to be? Brian? Sorry? What would the probability be for the second pig to be blue if the first pig were to already be blue? This one. What probability? What's number that you will write? I already changed the question. Yeah. To actually say that it is going to be not replaced. 4 over 11. Okay. And then what will the next one be? 7 over 11. What do you mean? What do you think about this part here? What would the probability be over here? 6 over 11. But you first want to be red, right? How many blue pens are there? 5, right? So it should be 5 over 11. 5 over 11, right? Okay, so then after that, the red, second one to be red will be 6 over 11. Okay? So now, part 1, probability that the first is red, okay? You can still take it as 7 over 12. Answer will still remain at 7 over 12 because in this case, if you were to consider the only two cases, red or red blue, okay, if you were to consider this, right, you will still get your answer to be 7 over 12. Okay? So part 1's answer not an issue. For part 2, second one to be blue given that the first is blue. Okay, so first one is blue, you want the second one to also be blue. So the probability in this case will be 4 over 11. Okay, but then if I want to find out, okay, the probability that the second is blue given that the first is actually red, these two probabilities will actually be different because given that first is red, second is blue, okay, then my answer will be 5 over 11. So it is different from how independent events will actually be because independence, both of these probability will actually be the same. Correct? Okay. Then after that, for part 3, probability that it will be blue. So blue will be 5 over 12 times 4 over 11. So that will give you 20 over 132, right? 10 over 66. Answer 5 over 33. Then after that, for part 4, which was our issue just now, okay, probability that the second one is blue, okay, second one to be blue, you find that if I were to just take the probability, then it will be different already. Okay, so we will actually have to do our calculation these two cases. So it will be red blue first, so that will be 7 over 12 times 5 over 11 plus blue will be 5 over 12 times 4 over 11. So that will be 5 over 12. Okay, so you find that second is blue. It is different from how you actually calculate in part 2 with the given condition. Okay, because just now earlier on independent events, you will find that the probability is the same, but dependent events, the probability is no longer the same. Okay. Then after that, for part 5 probability, there is no blue pairs. Alright, so that means red. So 7 over 12 times 6 over 11. So 42 over 1, 3. 7 over 2. Thank you. Alright. Any questions? Okay, so what I'm trying to say over here is that, okay, whenever the questions are about replacing or not replacing, it will affect the dependency of the question. Okay, so it will also affect the probabilities that you're going to list out in your tree diagram. And then you just based on your tree diagram, your understanding of the question, and then you do your calculations. Okay, because very likely as you go through part 1, 2, 3, you will forget whether is it dependent or independent already. Okay, so it will be better to actually consider what are the cases possible for that event to happen.
Part 4 is different.
Sorry?
Part 4 is different.
Yeah, but it has no. It is just now earlier on. Second one is blue. Is this part the answer, but 5 over 12 is there. Exactly. It doesn't make sense for you to take. Second is blue to take its probability, right? Yeah. Okay. So we will move on.